Tonight's event will be recorded, and we hope to upload it onto the IMechE YouTube channel at a later date. Q&A will follow the main presentation. Feel free to put your questions in the chat as we go through, and we'll pick those up to ask at the end of the event. Yeah, if you want to ask a question during the Q&A, please do raise your hand. Okay, so welcome everybody. My name's Toby Johnson. I'm the chair of the Railway Division Southeastern Centre, and I'm joined by Trevor Hardy, who is Technical Head of Telecoms at Transport for London. I've also got my colleague Tim Poole, who'll be helping us out with the Q&A later. So tonight, we're just gonna, I'll just do a few notices of our future events, and then we'll go into the main presentation for tonight, which is on rail cyber security. Our next centre event is on Thursday the 28th of April. We are joining up with the Milton Keynes Centre to bring you a presentation by Simon Skinner, who's Head of Engineering at Powerlines, on electrification, developments and delivery. That is a hybrid event, so there'll be a chance to either be there in person at Birdcage Walk or join us online. And that's going to have an AGM, our AGM at 5:30 before the presentation at 6. You should be able to click on that link, I hope, and to register for the event. If not, just head to our Near You website and registration details are there. Another event which may be of interest to some of you is another talk at Birdcage Walk, which is being co-run with the IET, and that's on the Gresley Class P2, Britain's most powerful steam locomotive, and that's Rob Morland of the A1 Steam Locomotive Trust, who's going to talk about how they have recreated that steam locomotive in the, I think it's called the Prince Charles. So that's another event that might be of interest to you, and the link there for signing up you should be able to access registration on that link. So that's it. That's enough from me tonight until the end, and I would like you to all welcome Trevor Hardy. As I said, he's Technical Head of Telecoms at Transport for London, and he's going to talk to us about rail cyber security. So, Trevor, over to you.
Okay, well, thanks for having me, everyone. Right, just try and make sure I've got my sharing and everything ready to go. Because that come up all right in terms of my front page?
Yeah, we can see your slide.
Brilliant. Right, okay. So yeah, thanks for having me along to talk to you today. I hope in the next 40 minutes or so I can sort of explain some of the sort of cybersecurity aspects of not just rail signalling. I've broadened the scope a little bit to include sort of the wider operational technology, and hopefully that will become apparent as we go through my presentation. But in general, all of the things that I'm going to talk about here have direct parallels within the rail industry, as well as a number of other operational technology areas that Transport for London is involved in. And the presentation starts off by sort of presenting a systems integration that I was involved in a small number of years ago within TfL. That's now part of a sort of bigger push on improving cybersecurity across a number of our sort of business areas. Right, so I'll get started. So the first question is cybersecurity really such a new idea? Now, hopefully this little anecdote will be familiar to some of you. Oh, bear with me. I don't think you'll be able to hear that. I know what I've forgotten, having prepared this earlier. There we go. Right. Okay, if you can't hear this, can someone put it in the chat?
No, we can't hear it.
Oh. Okay.
Worked earlier.
Yeah. No worries. This is a clip from. Does anyone know the film that this is from?
Italian Job.
That's right. So this is a clip from the Italian Job, 1969. Very much presenting the idea that you could disrupt a control system and actually deliver a number of sort of bad events that in some cases could cause people to have accidents, so all sorts of safety issues, as well as just generally causing chaos and ultimately leading to a breakdown in some cases civil obedience and general behaviour by members of the public, as well as obviously allowing maybe slightly less savoury characters to go about their business. And it's just really here as an indicator. As I say, there are lots of reasons, and we can maybe come up and have a bit of a discussion at the end of them around why or how the safety constraints of modern traffic signal control wouldn't let this happen. But it just sort of shows that the concept of a breach in security, allowing someone to disrupt a system that's considered safety critical, isn't a new idea. This is something that's been around in the way that we've operated technology for quite a long time. Okay, so one thing that I think is worth sort of calling out specifically is that people often think that cybersecurity is just about stopping people from doing things. And it's often people focus on the delivery of shiny technology, but in reality, it's as much about the people and processes as it is improving the sort of technological solutions that we have in place to operate our systems. And that's a theme that through my presentation we'll come back and talk about a little bit. As I say, it's very easy often to get waylaid and to focus just on what we can do in terms of delivering new technology, but actually understanding how people behave when they're presented with these kinds of challenges, or the processes that as organizations put in place are just as important in making sure we're able to operate our transport networks or other critical infrastructure. Okay, so as I said, I was going to cover off and talk for a few minutes about a project I was involved with back in, finished off in about 2018, that covers Transport for London's road tunnels. Now, there are 12 of them dotted around London, as I indicated here on the map, with a star, including 3 river crossings. So Blackwall Tunnel, the northbound bore of which was actually opened in 1897, is, you know, quite an old piece of infrastructure now. Southbound tunnel that was built in 1967 to relieve the what was at the time the 2-way operation of the northbound tunnel, as well as Rotherhithe, which opened in 1908, are the sort of three of the critical road crossings to the east of Tower Bridge in London. But TfL's responsibility for road tunnels covers all the way over to Hanger Lane in the west, 4th Street in the north, George Green and Green Man in the northeast, and down as far as Eltham in the southeast. And as TfL operate these tunnels very much as a ecosystem of tunnels. They've been managed historically, go back far enough, they were actually managed by police operators, and TfL took responsibility for operating those probably in about 2009-10, when the Met Police handed over operation of the road network over from a sort of police activity over to a transport agency role that TfL had. So just going to touch a little bit on some of the assets that we have within that environment. Some of these are very, very familiar to sort of the railway world. We have everything from CCTV, so we have generally full coverage of most of our road tunnels. A whole plethora of different SCADA assets covering everything from power, tunnel lighting, ventilation, pumps, fire detection, and all sorts of things in between. Not always integrated well together, sometimes just delivered as discrete entities when old assets have become obsolete. And in some cases, not every tunnel has every different type of asset. So depending on what the challenges are when the tunnel was built, or even the mechanism around how it how it was built and the systems implemented, you may not have every system available within every tunnel. We also have, because of the way that we manage the network, we have a legacy protocol that was inherited effectively from the Highways Agency of old, called NMCS2, which is used to set message signs and barriers within the tunnel. Very much our sort of version of sort of customer information when it comes to providing information to tunnel users. So that could be to tell people that that the tunnel's currently closed, or it could be to provide speed limit information, or in the case of accidents or anything like that, we might be able to deploy barriers to make sure that we can close the tunnel and stop people from entering the tunnel environment. As part of that, obviously, we've also got emergency roadside phones. So there's a mechanism for people to be able to phone back to the control room and confirm that they've broken down, or if they need any assistance from anyone. They're available again in each of the main tunnels and on some open road sections. We also provide a number of services when it comes to a sort of radio coverage, obviously, and public address. Now, public address is quite important in terms of being able to talk to people who are stuck in the tunnel, and radio break-in is very much a mechanism that allows us to break into people's radio transmissions. So if they're listening to a radio station on AM, FM, and we have also done DAB, then we're able to actually, from the control room, talk to the people in the cars and give them the information that they need to make sure that we can get them out of the tunnel safely. We also have radio coverage, so obviously things like emergency services radio, so at the moment Airwave, soon to be ESN, as well as obviously radio coverage for tunnel maintainers. And in some of our tunnels, we also provide sort of MNO, public cellular radio coverage, so people can continue to operate their mobile phones while they're hopefully hands-free driving through the tunnels. Since the Mont Blanc fire back in 1999, we've also been investing quite significantly in the delivery of automatic incident detection. So that's normally a video-based system, so we call it VAID, to actually identify incidents in real time and identify them to operators so that they can take the appropriate action. Just sort of gives us a bit of a flavour of the range of different assets that we have to deal with within that environment. As I say, quite a lot of parallels really with what's found more often than not on a railway. And I think the probably thing to say at this point is that, of course, one of the big differences that you have with a railway is that you're in control of the vehicles. One of the big challenges in the road network is that you don't have control over the skill set of the driver. They've passed their driving test at some point in the past, and depending on what they're doing and what activities they're undertaking, they may be distracted. And so incidents happening in the tunnel is a regular occurrence, whether it be breakdowns or in some cases some of the more severe things that we have had to. So if, for example, we've got a car fire within Blackwall Tunnel, now on average we generally have about one of these a year. Sometimes they're more severe than this, and sometimes they're quite they can be quite minor. There has been a number of cases where we've had we actually had a bus go into one of our tunnels while it was on fire and stop while it was in the tunnel rather than continuing through. And obviously that leaves with it a number of challenges in terms of trying to get the road network back up and running as much as actually trying to maintain a safe environment. The photo in the middle here is actually quite interesting because this is actually one of the tunnel vents for Blackwall, and it's quite interesting because, as I say, you don't generally get to see that kind of, you hopefully never get to see that kind of output when it comes to a railway ventilation shaft. But certainly on the road tunnels, they do get used, and these sort of sacrificial petals are more often than not made of wood, and if they burn, they burn. But fundamentally, the ventilation systems are absolutely critical in the sort of safe operation of the road tunnel environment. We also deal with all sorts of other incidents. So this is one from a few years ago where we had a crane operator, and if you look at the left-hand lane, you'll see that the tarmac or the actual road surface looks reasonably okay. And we had a large crane operator moving one of their cranes through Blackwall, had a hydraulic leak, and you can see as it's moved off into the distance, you can see a line of substance, and actually, as you can see there, a motorbike skids on it, and thankfully didn't come to any harm following the crane and its hydraulic fluid. But it's just another example of another one of those hazards that we have within the sort of the road environment. Interestingly, in this case, actually, the system that we had delivered helped us be able to demonstrate the fact that the crane operator had been negligent in driving their vehicle through the road tunnel and causing a disturbance. The tunnel was actually closed for just under a day. They resurfaced the entire tunnel and got it open again within 24 hours of the incident happening. But it's the kind of, just sort of sets a bit of an example about the kind of challenging environment that we have to deal with. So this is historically what the control center looked like. Effectively, you've got a bank of CCTV monitors. So I say there are 12 tunnels, and obviously we've got quite a lot of cameras in most of the tunnels. So you can't necessarily have someone watching all of them all of the time. So these cameras would generally oscillate around. So the operators would know where the Blackwall cameras would always be on a certain set of monitors, and then other tunnels would be displayed in different locations on the video wall. And then for the incident monitoring, the video analytics type of capability, we would have a number of these monitors in the middle that would come up and actually show you video from any incidents that have been triggered on that system. So you can see here that we've got 3 operators working in a normal daytime shift, normally with a supervisor with them as well. So it'll often be 4 people working in the control room managing that, and a lot of the job is about talking to other stakeholders. No different really from sort of talking to line control or centralized control or even station staff. Their job is to talk to all of the different stakeholders that they need to actually try and keep the operation running. So they'll be dealing with members of the public who have broken down on the emergency phones, and also talking to all the emergency services or the recovery people if they need to get someone to come along and get members of the public out to places of safety. But as you can see, it's quite a cluttered environment, and this is just an example of the desk. So we have everything here from sort of 3 handsets, 2 telephones, radio handset, CCTV control panel, sort of a system here for setting signs, and a fairly traditional SCADA HMI for doing the SCADA activities like opening and closing of or turning on and off ventilation plans and things like that. So it's quite a cluttered environment historically, and interestingly, you can see there's 2 mice and 2 keyboards. And in the heat of trying to deal with incidents, it was something that required a number of 4 people to be able to operate, to be able to deal with the kind of eventualities you might be trying to deal with in a normal shift. And this is sort of where we take a step back from a cybersecurity point of view. All of these systems weren't integrated. They didn't need to talk to each other. They were all independent. They could all be operated even if the other ones didn't work, which in some ways is quite a nice way to think about it. And it's maybe a little bit to sort of come back to one of the sort of film references. This was the Floodgate control panel for Blackwall Tunnel, which has a big pair of floodgate barriers that you could drop in the event of a breach of the tunnel. Not actually to protect people in the tunnel. This is actually to protect the surrounding area of London. So if you were stuck in the tunnel and the flood barriers had been dropped, you actually had stairs to climb out, and there was even a dinghy provided, so you could try or you would be able to get yourself out. But you can see the security arrangements around this, because obviously, potentially you're closing a floodgate and you may or may not be trapping people inside, and so the security around even operating this control panel within a secure control room is a little bit odd. Lots and lots of padlocks, and you need 2 different people to have the keys and push the buttons at the right time. And this is sort of how we've always approached sort of operational security. It's about making sure that the right people have the right training to do what needs to be done. But there's a bit of a challenge with that. It's all secure, you can't get to it. But if you want to try and move where your control center is, that's a lot of infrastructure to have to move. And so from a cybersecurity standpoint, yeah, it meets all the boxes. It ticks everything you would expect it to. Very, very unlikely to have any problems. And so from a historical point of view, the main OT cybersecurity control that we generally talk about in industry is air gap. Everything's air gapped. You can't possibly get from the internet or from an IT network onto your secure operational network. It's not possible. You haven't got any connections. And that's very much been one of the main sort of cybersecurity controls of the last sort of 15, 20 years, in terms of how people have actually operated their networks or their systems, and try and keep them secure. But obviously it has its problems. The first one is that we're all now used to using smartphones and having all sorts of technology at our fingertips. And so we were set the challenge as an organization to deliver a single user interface. And these are all the sorts of protocols and interfaces that had to be delivered to provide a single user interface for an operator within the control room to be able to do all the activities that at the moment they had 8 or 10 different independent systems. And effectively, that sort of changes the way things operate. Yes, you can still have things air gapped and you can still have a number of different controls, but effectively you're moving to a world where you are connecting things together. And fundamentally, to do that, you've got to look at networking. And so this is an example of the network that was delivered around the tunnels system. Thankfully, in TfL, we were quite lucky in that a number of predecessor organizations had actually invested in what was fiber optic cable in the heydays of the 80s when people were starting to look at deploying it. So actually, we're quite lucky in that we have our own fiber optic network, which means we can move data around pretty securely, and we're not really dependent on putting anything over the internet. In actual fact, one of the ethoses of how we delivered the network was that we wanted the control room to be able to operate without any external network connectivity. So effectively, we've moved that air gap from the devices or the system level just up one level to where we had effectively the system or the integrated system. So we still had an air gap, but it wasn't something that it wasn't local anymore to just one system. And that brings with it a number of challenges. So this sort of shows the complexity, and this very much shows the sort of the topographical layout within London in terms of how the tunnels networks are. But it has its challenges. We've got some sections, for example, the M1 Junction 1 down to Hanger Lane, where we've got our own fibre, but it doesn't connect into anything. So we end up having to effectively lease tails to provide that connectivity and that resilience that we require. And so again, that brings with it a number of its own security challenges. So connecting things up it's all very well and good, and you can start to meet the sort of business objectives of simplifying command and control methods, putting the right stakeholders nearer each other so they can communicate with each other. But you start to bring other challenges along with it. And so the network we ended up deploying kept a degree of segregation. So effectively, we ended up with running 7 different parallel networks. So the idea being that from a CCTV camera here in yellow, you wouldn't be able to go and talk to any of the roadside phones. And likewise, from any of the SCADA infrastructure, you wouldn't be able to talk to any of the other sort of radio infrastructure either. So you had segregation within the network, and that's always been one of the sort of cornerstones around how we do network design within operational systems. You don't really want people to be able to talk unless there's actually an operational need for them to be able to talk between different services. And so this actually comes from a manufacturing ethos that was delivered under ISA 95 called the Purge Model. And it very much talked initially around a sort of manufacturing ethos where you had your manufacturing infrastructure and all of your sort of detailed actual production was happening down at this sort of industrial network level. And these are sort of given zoned levels. But then any traffic that you want to get from that zone up to a higher order, you pass up through a conduit. So you have control through the use of a firewall in this case. You control what data can go between these different zones. And you replicate this all the way up through until you get up to what is ultimately your enterprise network. And so this method of conduit and zones is still really fundamental to how we generally control and manage OT cybersecurity. It's been evolved a little bit under some of the newer standards, such as IEC 62443, which have very much said that effectively these rules or these conduits and zones are fine, but sometimes you've got to think a little bit around which way you actually want data to flow. So one of the things that in recent times people have wanted to do more and more is do much more remote condition monitoring. So it's okay to bring data out of your industrial network and provide it up to your sort of DMZ or your higher order network, but you probably don't want any data to be going back in the other direction. And so that's always been one of the sort of key fundamental methods that we do things. So you segmentalize a bit here. So you've got two industrial networks. Again, that segmentation is important. Things that are in this network don't really need to talk to this network, and therefore you don't allow them, you don't put them on a single network. You effectively force them to be in their own segregated area. And then anything they do need to communicate in either direction gets to go through the conduit, and you can manage what goes through the conduit, say through the use of firewalls. One thing that's sort of worth pointing out when you're looking at these kinds of models is actually what is the real challenge in cybersecurity, apart from understanding that it's people, process, and technology, is actually what the risk is that you're trying to manage. Because each of these zones and each of these conduits, you're only going to put in place if there's actually a reason for doing it. What risk have you identified that justifies putting in place these conduits or these and zoning these kinds of segregations in place? You're not necessarily going to go down the route of saying, right, we're going to put these in place and do it all by the theory without necessarily thinking about what risks you're actually trying to mitigate. And that's one of the challenges a little bit with the Purge model is if you do it to the letter of the standards, you actually make things very, very difficult for you to be able to operate because you will have change control processes around how you change what's in these conduits. And when you're trying to operate an OT system, the focus is more often than not on keeping the actual industrial process operating, whether that be a railway, a road tunnel, or even a manufacturing plant. So I'm now going to talk a little bit around some of the kinds of controls that we have in our sort of toolbox. One of the key controls that we generally have is actually understanding what we have connected to the networks. So inventory and control of assets is really important. There's no point in having really, really good technology and good network control if you don't actually understand, and anyone can just turn up and plug into a network and have full access to all your assets. So that's one of the first sort of cornerstones of actually controlling what's going on within your OT domain. Another one that sort of often gets overlooked in the OT space is regular OS and application patching. Just as an example, on the road tunnels, when we did the migrations back in sort of 2017, 2018, 2019, we still had services that were running Windows 2000, which are very much out of date, very much not maintainable from a legacy standpoint. And there are no regular OS and patching updates. And that comes probably down to a fact that where's the investment come from to actually replace them? And if they're very reliable and people don't generally see the need for patching and managing OS upgrades within an OT space, that in itself can bring its own risks. So regular OS patching is quite important to think about, or at least if you're not going to do that, you need to think about what impact it might have. We talked a little bit around the use of a DMZ. So a DMZ is a demilitarized zone, and it effectively is one of those layers within the Purge model that allows you to extract and get data from your OT system into a higher order network that ultimately you may be able to consume. So there's a number of different ways. Normally you would have them firewalled off. So in effect, you are managing the traffic going between the OT network into the DMZ and from the DMZ into your more IT enterprise infrastructure. I've spoken a little bit around sort of the segregation, and we often refer to that as hub and spoke. So the idea being that generally, if you've got something that's a sensor, it's going to be sending its data to a hub site, so a site that can receive and talk to maybe lots of sites. But from each of the spokes or each of the roadside sites, you wouldn't necessarily want or expect to be able to talk to any of the neighbouring pieces of infrastructure. And the same would apply here, really, if you thought about a train. If a train is sending back its remote condition information to the line control center or to the control center, you wouldn't really want or expect it to be able to talk to another train. So from an architectural point of view, you're limiting the security domain so that you're limiting the attack vector effectively by reducing how much of the network an individual device can actually see. Talked a little bit about firewalls. They're sort of one of the things that a lot of times people say, oh, we'll just put some firewalls in. And that's fine, but again, they need updating and patching and reviewing. And one of the sort of cardinal sins from a cybersecurity world is putting one in and then having a allow star type of access rule where effectively you turn it off. So it's there, all the traffic's going through it, but you're effectively allowing traffic to flow through it without any impeding, which sort of does away for the value that it brings. And there are other ways that you can actually manage the traffic coming in and out of your different zones. Access control lists is actually is quite a good one. If you know and your data is relatively deterministic and you know where it should be going and what it should look like, you can actually set that up within the network so that you're not able to talk between different sites or different infrastructure and only allow certain protocols through to the control center. So if you don't want to be able to actually say do remote desktop, for example, you could limit that through access control lists. I talked a little bit about the Purge model. Some of the other controls that we have, depending on how big a solution you're putting in place, you might have some network monitoring. So a tool like SolarWinds, which could use something like SNMP or NetFlow to actually actively monitor the network. And if you go for a sort of fully customized product, you can actually, in some cases, monitor end devices as well. So network monitoring allows you to see what kind of traffic is flowing across your network, and whether any of your devices go down. And it's probably more useful from a network availability or actually recovering from equipment failures than it necessarily is cybersecurity. But understanding what you've got in your network is sort of the first path effectively in actually running to be able to actually identify when you've got some cybersecurity attack underway. Anti-malware, antivirus, again, useful if you've got a desktop or a server infrastructure, but not always the easiest thing to do when you've got embedded devices such as cameras, or a whole host of other, or even PLCs, to be honest. But it's something to think about in terms of when you're building a system. If you've got server infrastructure sitting in your OT environment, how are you going to get anti-malware and antivirus updates to it? Because that air gap means that at some point you're going to have to work out how you get those on there. Now, one of the methods that's often used is sheep dipping. So that's where you take your antivirus updates, put them onto a media. Traditionally, it used to be a CD or a DVD. These days, everyone's using USB. But the key thing is to make sure that you use an air gap system to actually verify that you're not introducing any malware or any viruses onto that OT system. And so you effectively scan the media. You normally start with a completely fresh formatted media. You put your updates on it, sheep dip it, put it on the sheep dip, and effectively scan it to make sure that it hasn't got any malware or viruses. And then you can go and upgrade or deploy it onto your OT network or OT system. And that would apply not just for updating things like antivirus or anti-malware signatures on systems. It could apply to the actual configuration of the systems themselves. So that's quite an important task, especially if you're maintaining that air gap. You're not really maintaining that air gap because at some point you're taking a piece of electronics from one infrastructure to another. So you're effectively bridging that. So if you're doing that, you've got to do it in a controlled and careful manner. One of the things that's sort of been on the list of things that people have tried to implement in the last few years in terms of OT has been sort of looking at intrusion detection systems. So actually something that sits on the network and looks effectively for, is this the normal kind of behavior that I would expect to see? And there is a sort of a follow-on to that that's very popular within the IT infrastructure called an IPS, which effectively actually would then go away and try and fix the problem. Now that brings with it a whole load of safety concerns when you're dealing with an OT system, because you've got to keep the integrity of the actual OT environment that you're trying to run. You can't accept it being shut down by an IPS because someone thinks someone's plugged in a laptop or something onto the network. The job of the OT network and the OT system is to continue operating. So IPSs haven't really become particularly popular within the operational technology domain. And as I say, certainly you might find them at certain layers within your Purge model, but generally not right down at the sort of the manufacturing or the actual industrial asset area. So this is what we ended up with. This is the finished control room. It did mean that it got moved from where it was, which was a sort of dedicated purpose-built building into a TfL office environment to be located with a lot of the other control centers. And actually, it was a lot fresher, a lot easier for people to sort of get to work, a bit more central. Had lots of benefits for some of the operators. But one of the key ones was that they went from having that whole plethora of assets sitting on their desk to having just 4 monitors, all one system, all customizable to a degree for the operator to do what they need to do. And ultimately, one handset for doing whether it's PA announcements, talking to people on the radio, or even talking to colleagues or stakeholders in the police force or any other organisations. So that was the outcome effectively of the project. It's an integrated solution actually delivered by a Spanish company in Spain called Indra, and that's now been in place for a number of years. Another little shot of sort of some of the more intricate details. There's an awful lot of assets within the tunnel environment, and actually to operate and understand what all of these assets mean takes quite a bit of training. So it's not something that, as I say, I've been involved in commissioning the solution, but I wouldn't pretend to be an expert at necessarily every tunnel. I think I was involved in the commissioning of a few, and there are some tunnels that are relatively simple. But this just gives you a flavour of the kind of amount of information and the operating environment. It's actually not that dissimilar from sort of a signalling system at the end of the day in terms of alerts and alarms and actually people getting pop-ups and having to deal with phone calls and all sorts of data triggers coming in. So that, of course, one of the things that system delivered was effectively a networked outcome. And one of the things that the business was very, very keen on having was a way of generating reports automatically. As historically, if a tunnel got closed and it was closed for very long, it would be on the morning London news on the television. Blackwall tunnel's closed due to whatever incident. And at some point within the organisation, there'd be quite an interest in understanding, is it going to open soon? What's the problem? Is there something we need to do? Do we need to get additional resources or staff down to help solve the problem so we can open the tunnel up? And actually, this system very much provided a means for sending reporting up sort of the management chain so that the organisation had better visibility of incidents as they were going on. Rather than having to distract an operator from dealing with the incident, they were able to effectively, the management could actually take an active report of what the current status is and what the current estimated ETA of reopening the tunnel was without having to even speak to the operators managing the control center. But it did bring one really interesting cybersecurity concern that we had to turn off. So the system being all integrated and sort of relatively modern, it had a web front end, and that was how the management were able to generate and collect their reports. It just so happened that it also had all the functionality that you could go in and understand what was going on with the assets. And it was through some testing that we were doing that I realized that through remote access, I could actually close all the London tunnels from my home over our IT remote infrastructure. So that was something that that was a cybersecurity incident, didn't come to anything because it was only in place for a short period of time. But it was something that no one had thought about in the delivery of the project until we started actually understanding, well, what could you do? How could you actually start to actually impact on the operation of the tunnels? And if you think about it, if you had access even through a standard IT infrastructure and you could do that, you could close it for 5 minutes and then open it. And the chances are, one, it wouldn't be safe on the ground, but also the people in the control room wouldn't have any idea who was doing it, because again, they would just see a user remotely accessing. They wouldn't see anything moving on their screens. They would just see the tunnel being closed. And so they'd have to go and look in the logs and understand what was actually going on. So it did bring a number of interesting cybersecurity risks that certainly weren't articulated when the project was being put together. So I've got a few slides that sort of cover off some of the things that have been going on in the last few years on cybersecurity. And this is always one that we refer back to sort of time and time again. It's in lots of contracts. It gets issued for, making sure that organizations and suppliers are aware of the 10 steps to cybersecurity. I'm not going to go through all of them because I think I've hopefully covered most of them, apart from sort of user education and awareness, which again, I'll come on and talk a little bit about in a minute. But effectively, if you're going to start off looking and understanding cybersecurity, these are the first 10 things that the National Cybersecurity Centre think you should be looking at doing. And that applies for both an IT and an OT world. It doesn't really matter. In some ways, you could even apply it to your network at home. Everyone's been working from home for the last year, and you might have all sorts of assets around your home that you could connect to. So cybersecurity doesn't necessarily just tie into the operational side of things. It's also how you deal with things on the IT and in some cases even on your personal devices. But this is a good grounding if you want to look at, something for starting to get some more information. The actual National Cybersecurity Centre website is very good at providing quite a lot of details. So in 2018, the EU introduced something called the NIS Directive, which is the Network and Information Security Regulations, which actually put an onus on what were classed operators of essential services to actually achieve a high level of security across their critical infrastructure. So Transport for London's been designated as a OES, along with London Underground, for a number of different systems. I think there are 17 in total, largely railway signalling, fleet, as well as, say, road tunnels and a number of other surface systems. And this actual regulation is something that we're still working on. So we have a competent authority in the regulations, and that's the Department for Transport. And the key thing is that under the regulations, they are able to fine organisations who are not meeting the regulations with a fine of up to 70 million to an OES. So it's quite a significant cost if in actual fact we're unable to meet the regulations. And one of the things that it does is it brings with it a number of requirements, one of which is to report significant incidents on our critical infrastructure within 72 hours of an incident happening. It doesn't actually matter whether it's a cybersecurity incident. It could be an incident that could be caused by a cyber incident, still has to be reported. So especially if we've got services that are being impacted, and it is often referring really back to the impact rather than necessarily what the actual failure was, it would be reportable under the NIS regulations. The other part of it was quite a bit of work had to be done in actually understanding how good a job we were doing at managing our cyber security environment. What was our security posture like? And so this framework was developed by the National Cybersecurity Centre to actually help us classify all of our systems. So for every NIS system, you have a CAF, cyber assessment framework, that details how well you're doing against a whole host of indicators of good practice. Now, there's an awful lot on here, and as I say, I wanted to at least present it because this is effectively breaks down into 4 areas. And this doesn't all relate back to technology. So governance, risk management, asset management, supply chain, it's all about managing your risks. So you have to understand what your risk is. And it might be that you've got risks through the suppliers that you're using, who you chose to contract with in the first place, or what you've put on them in your contracts. Those are all kinds of things that can impact your cybersecurity risk. Obviously, the sort of defending against attack and detecting events is probably more on the technical aspects of some of those things, how you've built your systems and how you're monitoring those. And then the last section D, is on about minimizing or recovering from incidents. So this framework's actually been the thing that we've spent quite a lot of the last sort of 2 or 3 years working on to make sure we understand our sort of security posture. And one of the main things that I sort of said at the beginning about people, process, and technology, A is almost all about people and processes. But C is probably more so about the technology. And there's been a piece of work that we've been doing with a company called Nozomi Networks, where again, they are a OT-focused cyber security detection capability. So they have a product called Guardian, and we've implemented that on one of our OT systems using this thing called a Guardian sensor. And what that can do, it sort of helps tick a number of boxes on that cyber security, that CAF, that cyber assessment framework. So you can put it within your OT network, and it can effectively sit there looking at what's on the network and learning and understanding what's there. And it can, so you can deploy a number of these, so you can build them out in quite a wide-ranging setup. You're not constrained in terms of it's scalable. You can deploy multiple units as required as you go. And then you can start to actually get some real data. So you can start to actually understand what kind of alerts you're getting and what kind of assets you've got, and whether you've got vulnerabilities on any of those assets, and what things are changing over time. So, and you can see here that you can actually see the different assets that might be in each of your different Purge models within the network environment. So it's proven to be quite an interesting tool, and certainly helps us tick a lot of the boxes in terms of understanding the security of our OT domain. So the TFL trial of that, and the way that this has been implemented, is again trying to make sure that it's scalable but also secure. So fundamentally, we haven't actually touched or added any assets to the OT network. What we actually done is added a managed switch here within the OT network that has something called a span port that effectively reports or is able to provide an output from the OT network of all the data that's flowing within that network. That then gets passed through this device here, which is called a data diode, which allows traffic to come out of the OT network, but doesn't allow anything to go back in. So you can't compromise the OT network by talking to any assets through this link. And then within the OT-DMZ, you then aggregate and understand the data that you're receiving using this device called a Guardian. And then you're able to populate that up through your Purge model, through into your IT network, and ultimately onto the cloud to provide that rich, real-time picture of your OT environment. And if anything changes, you'll get alerts, and it learns over time. And it's quite an involved process. So we haven't done that in lots of details or necessarily on lots of live systems, but this is the direction of travel for us as an organization in starting to meet our sort of detection requirements within the NIS regulations. So one of the other things that I sort of wanted to touch on is there's another concept. The Purge model's been around for quite a few years, and quite a few people say it's dead. These days, with everyone wanting everything on their phones and everyone wanting everything now, the concept of having to go through all of these different zones and up through these different conduits is antiquated. And actually, we should move to this concept of zero trust, where effectively you don't trust anything on the network until it has authenticated and you've actually given it, it's actually come in and told you what it needs and what it is. And it's quite an interesting and it's quite an ultimately a big change to how we might choose to do security within the OT world. Because effectively what you're doing is you're actually having to coordinate both your assets and your users and the systems that they're using all together to make sure that you have a more dynamic environment, which means that it needs a lot more managing. So there's quite a lot of things going on at the moment in terms of within the industry to look at this sort of zero trust model. But there are a number of principles that are worth calling out. The first one is you verify everything. So you always make sure that you know what's actually on the network, who's on the network, whether it be a person or an individual or whether it's an asset. You verify and you make sure that it's the same asset or person that you've agreed it to be. And you can do that through things like location information. So if someone's connecting in from outside, you can check where in the world they are. It could be done through data classification. It's like, well, we know that this is an asset. Maybe it hasn't got all the security attributes that we would expect it to, and therefore you verify that it's there and you assume it hasn't changed. But maybe you don't trust it quite as much as something that you actually got a better ability to authenticate and authorize onto the network. So another concept is least privilege. Why give access to the entire network if you can just give access to just enough? So what actually does the user or even the actual application or data need to be able to do? So you can take a risk-based approach that says, well, this person only needs to be able to see these assets, therefore that's all they can see. It limits, again, the attack vector that if someone does manage to breach their account, what they can see within the network. And the last principle is assuming that there's a breach. So you have to have all of that sort of concept of everything being monitored and understanding what's going on the network. And also make sure that everything is encrypted end to end. It makes it much harder to break into the middle of things and understand what's going on the network if you're already encrypting your traffic end to end. Now, all of these principles bring with them challenges within the OT space. And as I say, I'm not sure entirely that the jury's come back with a yes, this is the way we should be going as organizations. And I think ultimately there's a need to do a risk assessment on each case. But there will be times when the Purge model is overkill and is probably antiquated, and we need to accept the fact that people want to be able to get data in and out of systems, and we just need to make sure that we have appropriate controls and mechanisms for managing that. I've got one more slide on the sort of zero trust model, and this sort of shows the sort of the flow. So effectively, you take a device or a user and you work out what their risk is. What are they likely to be able to do? So have you been able to multi-factor authenticate them, whether that be through an app or a phone or a number of other things? Are they coming in from an unusual location? Have you been told that their password's been leaked and you don't necessarily want to trust them? And the same could be true with devices. Has something changed? Has the device been updated? Has it got a new signature which isn't necessarily what you expected or or you've set not to actually be acceptable, because someone's done a firmware update in the hope of infecting the actual system by updating that asset. So there's a whole host of different ways that you can provide that level of risk. And then the next thing is to look at actually having a policy that says, well, what do you do with that information? How do you decide what you're actually going to give people access to? And then effectively you have on the right hand side your sort of enforcement of the applications, or what it is you're actually letting people do. So you might have the ability for people to edit documents or view works instructions, all sorts of things, all the way through to giving them access to legacy applications and things like that maybe you don't have as many controls, or maybe they still need to log into as an additional level of security. So another thing I thought I'd mention is, can we put all our control systems in the cloud? And the cloud is the thing that most people are talking about. Most of the time now we're talking about putting more and more things in the cloud, but there are new challenges. They're manageable, but it's going to be more about deciding what needs to go into what environment. So you're not going to be installing sensors or actuators in the cloud, but you might put the reporting and the monitoring there because it's an efficient way of doing it. But it comes back to managing that security domain and managing the risk. What is the impact if in actual fact that cloud environment stopped working? Or what would be the impact if it was moved from one location to another? The challenges are different, but it's all of the controls that we've gone through today, all generally are applicable, whether it's in a cloud environment or not. And a lot of the time, it's about making sure we're able to actually continue to operate the service. And I think the final thing to say on cloud is, yeah, the challenges are different, but it's at the end of the day, it's just someone else's computer. It's no longer yours. So just because it seems an easy way of doing things, and it's a way to move towards certainly more software-based solutions where you're not necessarily having to worry about installing hardware and having to house what could be expensive equipment, at the end of the day, someone's got to do that still. Otherwise, you haven't got a system to run your OT environment on. And finally, I think I'd sort of bring it full circle and come back to the people thing. It's really important that, as I say, most of the vulnerabilities that get exploited, or most of the way that people actually get onto systems, especially in the OT domain, is very much through people. A lot of the time, we are not necessarily particularly good at managing how people behave when they're maybe under stress. Maybe they're given a challenge that they aren't quite used to, and they provide information that provides an attack vector for someone to get onto a system. And I just thought this cartoon sort of summed it up for me. Maybe it's the slightly geeky person that I am at times, but at the end of the day, especially in the history of sort of OT environments, we often find that people have shared system passwords or shared passwords, and realistically, it's the people that are the problem when you've got those, not the fact that the system has got one password. It's how you manage access to those pieces of infrastructure and who you give access to the passwords to. And that very much brings me to the end of what I was going to present.
Well, Trevor, thank you very much for that. Really interesting, incredibly thorough. First of all, I'll just propose a vote of thanks for all these fantastic examples, especially around the tunnel systems, TfL's tunnel systems. Got a very comprehensive list of typical cyber controls. We learned how important it was to have processes and people as well as the technology. The risks of no air gap, and how that looks like the way we're going in the future, even touching on the cloud, and the fact that there's a £70 million fine for getting it wrong, which must hang over you somewhat. But I think basically anyone who's watched this, taken it in, and then looks at the presentation and the slides after, would be very well equipped indeed to understand some of the challenges of keeping big systems like on transport cyber secure. And I can just thank you very much for that. And I think that was very comprehensive, very good. So from all of us, thank you very much. And would you answer a few questions if there?
Yeah, happy to answer any questions.
Right, well, I don't know how I'm going to do this because there's obviously a huge list of names and I can't see all the hands at once. So if you've got your hand up, just tell me. Just shout your name one at a time. PH, whoever that is. Please fire away.
That's perhaps me, Phil Hind. One of the things that I'm now retired, of course, but in the last few years of my working career, increasingly involved with software testing, software reliability, making sure that the functionality coped with all the scenarios that will be thrown up against it. Cybersecurity was very much coming into the picture, but be interested on your view on where you've got a new system. So you're kind of debugging the software, control software at the same time as you're worrying about cybersecurity. How do you take the two issues forward together?
Ooh, that's an interesting question. I think functionality testing and sort of making sure things function in the way that you want them to in your sort of sterile environment is still really important. I think it sort of comes back to the need to actually do thorough testing. One of the challenges that I've often faced from organizations has been that, well, the supplier is just going to deliver what we've asked them to deliver, so we don't really need to test it. And so there's two aspects to it. The first one of which is generally that even if you've got a really good supplier, you will find things out, or they will find things out through doing a decent amount of testing. And the second thing is doing security testing is often left right until the end of the process. It's one of my sort of bugbears with system delivery. Often we wait until the system's even installed. In the case of road tunnels, actually, we waited until it was installed in the data center, and then we got someone to come in and verify that all the security controls that we'd put in place had been done. And in some ways, it would have been better to do it earlier in the life cycle and actually done maybe testing at a lower level. One of the challenges, certainly in the road tunnel environment, is just the sheer number of assets. So the problem is responsibility, and this comes back to sort of contracts and planning for how you deal with things more at a commercial level, to be honest, than a technical one. We've got a different maintainer for the assets that are within the tunnel space than the system, which brings its own problems, because when we're specifying and we want new products to be delivered, we're managing the integration between the asset and the integration on the system as a whole. And so sometimes it's easy to sort of stick to we've done it this way before and that's what we're going to do because we know it will work, without necessarily looking at, well, what security implications does that legacy infrastructure have that really we should be looking at moving away from. So I think that's the only thing I'd say, is that really need to try and look at doing it earlier in the life cycle. And actually having security I didn't talk really very much at all about secure by design, but that's very much a philosophy that as an industry we need to move towards. But that almost ties back to the fact that by default things should be encrypted, and it's not, I've probably been as guilty as others in sort of saying, well, we don't need to encrypt it. It's on a secure network. It's okay. It's not actually safety critical information. It's just information. It'll be okay if we don't encrypt it. And actually, if you're looking at delivering things in a secure by design manner, there's absolutely quite a lot of work that can be done that says actually you encrypt it, not because necessarily you think that that's going to stop you from having a problem, but because it means that you know that the end-to-end data path is protected. It sometimes makes things harder for testing and troubleshooting, and that's one of the big challenges. Can you turn it on and off easily enough to understand what's actually going on? Hope that goes some way to answer your question.
No, it's an interesting response, and I think you've hit the nail on the head that the earlier you start thinking about all aspects, probably the better.
Thank you very much. Graham.
Hi, Trevor. It's Graham
Hello.
Neal. Nice to see you again.
Nice to hear from you.
It's also nice to hear Phil Hind, an old friend of mine as well. This is a bit tongue-in-cheek, but how useful are hackathons to try and test systems like the ones you're talking about, the OT systems? I know they've been used by other industries to test their security. I just wondered what your view is.
I've got two views. First one of which is, find me a representative test environment that it would be safe to play around with on a hackathon, and I would like to see your business case and how you got it through, because I've been at TFL for 18 years. I think I've had 2 or 3 good test environments that have existed as long as the systems have been in place. That's the first aspect. And I guess the second one is, do you think, well, it comes down to how well or how open those systems are. There's a lot of fairly bespoke protocols, or maybe not even bespoke protocols, but bespoke ways of doing things that I think means it's quite difficult for people who are not au fait with the system to really get to grips with actually understanding what's going on. So I'm a bit skeptical, if I'm honest. Hackathons, I think, are quite good for trying to put things together or to deliver outcomes maybe from data sets that you already have. But hackathons to look at, is this system vulnerable? Yeah, I'm not 100% sure what benefit really. All you're effectively doing is almost airing your dirty laundry in public, maybe.
I did say it was cheap.
Thank you very much. Well, and on that line, on the chat, Trevor, we've got a question which says, do you see penetration testing becoming more integral to cybersecurity of operational technology? And what issues to think about? And I would imagine that's similar response. Funding
is the biggest issue, and also scoping. One of the challenges that we've got in the road environment and the tunnels network that I've been involved with some of those roadside assets for over 10 years is actually trying to get a justification for doing regular pen testing when in some cases those assets don't change very much. There's sort of a number of different approaches to pen testing, and I'm probably much keener on where you're using commoditized software platforms or commoditized assets, looking at vulnerability scanning or vulnerability management much more so than pen testing. Just because if you've got off-the-shelf components, are you running the most up-to-date version of those off-the-shelf components? Have you considered the fact that, there's been quite a lot of fairly significant security breaches, things like Log4j late last year, absolutely, brings with it a whole host of challenges that you don't have to do a pen test to identify. You should know within your system what libraries, what software applications you're using. And if you haven't got that, you haven't actually got a very good control of all of your assets. So at that point, doing a penetration test to prove that you don't know is you only really do a pen test because you don't know what level of asset you're running with. So I would almost peel back a little bit and say penetration test is going to be more integral and more important, but you've got to be able to get the funding to do it. And actually a more regular thing should be a vulnerability assessment. And maybe you do a pen test when when you're trying to check whether you should be doing some other investment on other things. I don't know. It's a really difficult one. I haven't found, as I say, on the road tunnel environment that I talked a little bit about, we've got probably 30 or 50 different types of asset, and I could probably scope out a pen test for each one of those that took a week. Organizations can't afford to do that when a lot of the products are probably end of life, and even if we found a problem, the impact is you've got to start coming back to the risk of, well, what happens if that asset gets compromised? What does it actually mean to the operation of the OT infrastructure? Because if all it means is you have to turn it off and on again, sorry to come back to the IT sort of mindset, but if that does the job, then that vulnerability, you need to be able to detect that vulnerability and then recover from it rather than necessarily fix the vulnerability in the first place. It very much depends on the safety aspects as well. As I say, it's certainly not a hard and fast outcome, I think.
Thank you. Are there any more questions for Trevor from the floor? There's none on the chat.
Yeah, sorry, I didn't put my hand up. I'm just going to jump in. Sorry, Tim. It's Toby here.
Hello, Toby.
Yeah, I had a sort of quite a straightforward question, in the way one of the pictures you showed of the controls on the floodgates at the Blackwall Tunnel. You had the two padlocks, which kind of, I suppose, was a security measure against the malicious
rogue operator. I would
rogue operator. And I just wondered if you had any thoughts on how that can be controlled and
well, I think
in some of the modern OT systems.
Talking about the people side of things is one of your biggest threats with any OT environment where you're dealing with this kind of thing is going to be rogue individuals in your organization. And that's where that monitoring probably becomes even more important than what you've had before, because it doesn't really matter actually at the end of the day whether it's someone coming in from outside because something's gone wrong with your perimeter security, or whether it's someone actually who spent months and months understanding how you operate and what you're going to respond with. And I think that's part of the challenge. The Floodgate one, the reason I put the slide in there is a little bit a bit, maybe even a bit tongue-in-cheek or a bit provocative actually, because the reality is the keys for it were kept in a glass case above, very, very much like, don't use these, and if you do, you're going to have to break some glass to get into them. And having sat there when actually we were trying to test them for the system integration, to actually get the floodgates to actually come down from the ceiling, I actually had to get up there with hammers and you know, and actually hit them to actually free them up so they could be operated. So it's one of these things where, again, you know, I don't know how often they used to have a 6 monthly test, but realistically, unless you actually test all of your functionality within your systems, you're never going to be able to guarantee that they're going to work the next time you want to use them. So if you've got backups and that, you know, or resilient systems and you never test the resilience, you may as well not have them, because you're not actually going through the action of testing them and verifying that they're working regularly enough. And it's the same really with the keys. As I say, you could have turned up with some bolt cutters and literally chopped through the 4 padlocks and just pushed the buttons to bring them down. Physical security is always going to be your sort of bedrock. And as I say, that was a control panel located in a secure building that you couldn't get into particularly easily. But even then, half the time, would the operators really be too scared to do it? Because in some cases, if you actually had water in the tunnel, you're probably, unfortunately, sending people probably to their death.
Right.
You know, unless they were agile enough to be able to climb up, you know, stairs and sort of escape out of the escape hatch at the top. It's not something necessarily that I think operators necessarily have the full training for. Be interesting actually to do a comparison, because of course LU have got some floodgates, but I don't generally think they're necessarily in any usable state. But that's probably a discussion for another time.
I don't know whether they've ever get tested. I suppose that perhaps a similar analogy might be the sort of the line controller who has to set a point, you know, set a set of points to derail a runaway train or something, and having the, you know, not knowing the consequences of that, which happened when they had the runaway grinding train on London Underground. So yeah, a lot of factors involved when it comes to the people side of it.
Well, and that's it. We don't always think about how people react to being put into those situations. So, you know, it's a bit like the airline pilot training. You know, they respond with a reflex to actually do that activity because that's what's been trained into them. I don't think from an OT security point of view, we necessarily do that level of training for our operators. Certainly, I don't think we do on the road tunnels. I can't really speak on the rail side, but you know, you're expecting people to do the best job that they can at the time that they've got to make that decision.
Thank you.
Thank you. Any more questions? I can't see any. All I can do, Trevor, is, of course, we're online. I can't ask anyone to give you a round of applause, except if we can do that with the chat system. But thank you incredibly much, hugely, for coming and presenting this to us this evening. It was incredibly interesting and very comprehensive. I think we're all very much the wiser. Thank you.
No problem. So I hope it was the right level of detail. It's always difficult because you could go into lots more detail in some areas, and yeah, as I say, apologies, I didn't start off by saying what OT was.
Technical is good. Absolutely. Thank you.
Well done, Trevor.
Good night, everyone. Thank you for coming.
Thank you.